Hello, everyone, and welcome to episode 8. Before we begin the formal presentation, I'd like to take you through some of the features of the webinar system. If you have any problems at all, please use the question field in the control panel on the side of your screen, and we'll try to help you out as much as we can. We'd also like to encourage you to ask our presenters any questions you might have as you think of them. Please use the same question field on the side of your screen, and we'll try and work those in as they come about. And of course, we're going to save some time at the end for any questions that come up that we can't get to in context. You'll be receiving an email tomorrow with a link to the recording of this webinar, and please see the handouts section in the control panel for the handouts from today's session. You'll notice the slides are there along with a couple of handouts and representative examples of what PatSeer can do, some additional examples beyond the one that we're going to go through today. And so, yeah, please grab those handouts. And finally, please, at the conclusion of the webinar, there's 6 questions. The survey is very short. And first and foremost, the #1 question on the survey is the folks from PatSeer are graciously offering a free trial for anybody who's interested who attended the webinar today. So all you have to do is say yes, and they'll be back in touch with you about how you can get access to the system at no cost to you to try it out and go through some of the things they're talking about today. All right, and so hello again. Welcome once again to episode 8 of the ML4Patents.com webinar series, this time featuring PatSeer. My name is Tony Trippi. I'm founder of ML4Patents.com and managing director of Patent Informatics. And I'm joined today by Manish Sinha and Rohit Joshi from PatSeer. And with that, I am going to let them do the talking. They're the ones that you came to see and hear. And so, Manish, the floor is yours.
Thank you, Tony. And good morning, everyone. Good afternoon, depending upon where you are. And firstly, I would like to thank Tony for organizing these series of webinars. And we are at PatSeer. We are glad to participate. And I really like the structure of the overall webinar, especially the topic of the qubit data set, on which today we will be demonstrating how PatSeer's AI functions work against that particular topic and that particular data set. So with that being said, let me first just take a step backward and introduce myself. My name is Manish Sinha. I am the Chief Technology Officer at GridLogix, and I lead the product development and the overall technology strategy at GridLogix. I have close to around 15 plus years in the patent space, and my background is in text analytics and machine learning and statistical data analysis. So that's a little bit about me. My colleague here, Rohit Joshi, he's our customer success manager at GridLogix, and he's for the last close to about 12 years, he has been helping our clients with various ways of how our products can resolve their challenges. So he'll be my co-host for today's session. So going further, please feel free to post your questions on the chat, as Tony said, and I'll be glad to take them up as I proceed in this webinar. So quickly, taking a quick introduction into the company. Many of you would have heard about PatSeer, and the company behind it is GridLogix. We are a focused company into intellectual property solutions, and our flagship product, PatSeer, is in use by companies, government institutes, law firms, service providers, and firms ranging from startups to Fortune 500 companies. So we're headquartered in India, and we currently PatSeer is close to around in use in around 36 countries, and with more than 400 to 450 clients. So that's a little bit about GridLogix. PatSeer, our platform, is actually a patent research platform, and it caters to a wide range of needs. It's designed to actually deliver specific needs to different teams at different stages of the innovation life cycle. So what you see on the screen here, there are different editions of PatSeer, and they are suited for different types of users. So if for dedicated search professionals, it's fundamentally a professional search platform to begin with. So our editions, PatSeer Premier, is actually focused towards information professionals, search professionals, and library and information scientists. And we have PatSeer Pro and Pro X, which focus more on the quantitative and qualitative analytic capabilities. So they're in use by technology managers and CI professionals and IP managers. And then we've got organization-wide solutions for collaboration and patent information dissemination, and which is PatSeer Explorer and projects. And as I said, the platform all these editions talk to each other. So people combine different sets of these for different classes of users, whether it is the class of users who are the reviewers, or the class of users who are just view only, or the class of users who are really doing all the analysis and data manipulation, and of course the people who are populating the data, which are the searchers. So they can all be having access to these different editions and be collaborating on the same data set. So that's a little bit about PatSeer. And fundamentally, quickly, just taking a step before we go into the topic for today, is what is the data that drives that basically all the stuff in PatSeer is built over. So it's got content of approximately 108 countries, and it's a bulk of that 73 countries is in full text. And like we said, it's a professional search platform. A lot of our users are information scientists and guys who go really deep into the search strategies and the data. So it's very comprehensive on the patent coverage aspect. We also combine designs, standard essential patent data. We integrate patents in order to drive intelligence beyond just IP and the technology held within the IP. We correlate that with additional data points. So we connected with corporate information, corporate hierarchies information. We connected with litigation information. Currently, we have US complete litigation information, and but we are extending that to 9 countries this quarter itself. And we've also connected to standard essential patent data, legal status data, and of course certain other derived value-added metadata like quality metrics. And so the intelligence that you get is actually working by correlating the data points across all of these different perspectives, or different vantage points. So moving into today's topic, I want to first just talk a little bit about our semantic engine, which we call as ReliSense. We coined ReliSense from the phrase relevance that makes sense, because you could run an AI engine and could throw up some result. At the end of the day, it needs to make sense, and then there are terminologies like precision recall and all of that to identify that. So that's how the ReliSense name has come in. So what are we calling what is ReliSense? It's basically a backend semantic engine that we've developed, which is basically a corpus of trained from the patents, and it is basically a bunch of semantic rules. So you can think it of as semantic vectors that we have taken in, which are basically categorizing the context against a reference. In our case, the references are IPC and CPC classes. So what we've done is basically we've mapped that term A closely comes with B, C, and D in these IPC classes, or we map that term A can mean X, Y, Z in these IPC classes, whereas it can mean M and O in another IPC classes. So why we have done this is because we leverage that to be able to derive the context of what you're searching, and that's how it enhances the semantic search or the natural language search capabilities that are there. Of course, it also helps in categorization. Like I said, it stores information of what words mean or can mean the same thing in different fields of science. So that's leveraged, that's used for inbuilt categorization, which we'll see in this presentation. And of course, we're also going to see how the semantic engine works and how efficient is that. So that's what we call it ReliSense. It continuously gets updated because it's integrated with our data pipeline platform. As newer content keeps coming in, the rules keep getting automatically updated in it. So as you know, the patents are themselves categorized with IPC and CPC classes. So there is some level of a manual. There's some level of a manual information for data modeling already present there, and that's what basically we leverage to automatically keep this being enhanced. So that's really what ReliSense is. We have even leveraged a non-patent information and mapped some of those based on our knowledge of what classes they would belong to, because the IPC CPC classes we are referring to here are really the 4-digit level classes. So we've done some of that also, so that it can function beyond the latest, so that because the latest technology information is probably more cutting edge, is coming in from journal data. So that's why. So with that being said, we're going to go into today's topic, and I'm going to take a step back here and talk a little bit about, as you know, there is a qubit generation gold standard data set, and Tony's been part of the team that set up that data set. And you probably also heard in some of the other presentations in these series about what the data set is about, so I'm not going to repeat it here. But it's essentially focused on qubit generation, and it contains close to about, I believe, 1,500 families, out of which there are 500 of them which are actually talking about qubit generation, and the rest are not really there. So they are negatives, and they are not talking. They're related to quantum computing, but not really related to qubit generation. So that's really the data set here. And our purpose today we are going to show you examples. So first, we are going to show an example of semantic search using a qubit generation patent, and we're going to see how the relevance of the results are matching. We compare that against, one, the backward citations of the same record, and two, the data set, the qubit generation data set. So I'm going to now get into the particular example that you're seeing here. As you know, D-Wave is one of the larger or the more prominent players in the qubit generation in the quantum computing space, and we picked up a particular patent of D-Wave, and I'm actually going to just show you how we went about it. So I'm into the software right now, and I just simply searched for all patents. All patents. I'm just selecting D-Wave here, and I'm going to jump to search. So in order to decide which patent to pick up, we really wanted it to be one of the highly ranked patents, and as Rohit will explain in later in this webinar, we have this whole ranking system, scoring system that identifies. So all we did was we just sorted the results by the quality score in a descending fashion, and it threw up this particular patent here, actually these are the same patents. It's a family. I did not deduplicate my results, but this family is the highest ranked family as per our scoring system in the of D-Wave in the data set, and so we just basically selected this one. We also cross-verified that this particular patent belongs in the qubit gold standard data set. It's part of that, and we also checked D-Wave's website, and the particular patent is actually it's actually present against all the products listed on their website. So in their patent notice section, they have all these different products of theirs, and this particular patent number, I've just taken a screenshot here. It is actually present as part of that. So to summarize, it is one of their it's one of their higher valued patents and core to their fundamental invention. That's why it's present in all their products. So now details of the patents, the screenshot is here. This describes the details of these patents, and it's pretty much it's active in these major jurisdictions. So to run the semantic search, what I've done is basically, and this is what we usually recommend also people, is that at the very minimum, if you're putting in data, then it should contain the abstract and at least the first claim or the independent claim, the key independent claims. It's not just be the title and abstract, because they don't really describe what the invention is. So what I've done is, for this patent here, I have copied its title and abstract. I have it right here. This is the particular, this is the same patent. This is the title, abstract, and these are the first, I think, one or two claims I've taken. And I'm going to actually do a live semantic search here to show you how it works. So so I'm just going to paste this paragraph here, and I click on search. So what the system first does is, it first identifies the relevant technology terms present in the input paragraph, and there's a whole set of logic and machine learning logic that is going in here to make sure that the important terms are highlighted, and which also includes looking at the frequency of how popular the term is in the particular space, and using a TF-IDF, deciding if it's just too popular, then it just doesn't, it's not relevant. So things like maybe compound or input structure, or communicative coupling here. It's just it leverages a bunch of rules to really identify this. We still give it to the user as a first step, because the user can decide if they want to modify it. If they don't want anything that we've selected, they can cross it. They can select a phrase and add it to if they feel something is important. For the purposes of this demo, I'm not going to modify it, and because the comparisons we've done is without modification. We just want to take the system as it is, get it closest to without any manual input, and see how good it is. So that's why I'm not going to modify any of these highlighted terms, and I'm just going to go click on submit here. So now at the back end, the system has run, it does a little bit of a homework already when it has given you the keywords, and that's why it helps in performance there. It's thrown up 512 families as results, and this particular family, it's showing me the EP record from that family, but it's obviously matched with number 1. But that's not what we are looking for, because what we are really looking for is how good are these results, and in terms of how do we benchmark, how close are these results, and how relevant are they. So the traditional traditional technique has been to really compare them. First is how much of the backward citations of the family has been really captured in the results, and I do have some analysis presented, and I'm going to show some of it live, but some of the analysis is offline. So I will, but I'll still try to, for transparency, I'm trying to, I will try to show as much as possible that is live. So if I go back into my presentation here, just to kind of give you some analysis, the particular patent, when we are comparing, to begin with, let me compare how the semantic search performed with the backward citations of this particular patent. This record has 32 backward citations belonging to 16 families. So it's basically 16 unique family citations there. And now, what you have seen in the semantic search here, we haven't given a date restriction because it was a text-based semantic search. It was not a kind of a novelty search done on the patent in which we would have probably combined it with its priority date in the query. So we've actually restricted when we restrict the semantic search to records with priority date lesser than this particular record, the US record, it gives us 93 families. And the comparison, and I have those families, what I've done is I have those family IDs with me here. These are all the 16 backward citations of the particular record. And just to demonstrate it here, I'm just going to actually put this here and filter it. So 12 families have actually matched. My input data here has 16 families, and these are all the citations, backward citations. So the first analysis that we have is 12 out of 16 citations were matched, and there's some further digging that we have is which ones did not match. So if we really want to see which ones did not match, I'm going to actually put that back into the query here to kind of explain that what could be probable reasons they did not match, and that could also be interpreted as where systems need to improve upon. So the first one we will see. Okay. Sorry, these are not part of the results, so I will actually have to go outside this result and run this. But before I do that, let me first analyze. Let me just talk a little bit about what matched. Interestingly, 3 of the backward citations actually matched are at positions number 2, 3, and 4 in this particular data set. We did a comparison here. We did a deeper analysis here, and the first 3 results after the family itself are its backward citations, which is quite useful if you're doing any kind of a novelty search, and you have such relevant results in your first page itself. And we were able to capture all the examiner citations on the original US record in the semantic result set, and 1 family level examiner citation was also present, so it was from its counterpart. And amongst the 4 unmatched citations, and I can run that query at a top level, 1 is a Soviet SU record, which is basically its full text is not available. 2 are Japanese, so they are non-native records, and 1 is a US record from 1979. So this is probably the SU is very clear because its full text in English wasn't available, so that's why it did not come in. But older US record in Japanese are just the ones which were missed by this, and that's really how. And I've particularly decided to explain this without using the typical percentages of precision recall and F1 scores, because I just wanted to keep it very simple in interpretation here. And but all the data here can give you I can easily calculate the precision value based on what's present on the slide. So yes.
So that's not a surprising result. I think it would actually have been a little more surprising if you had gotten all 16. It's very typical. I mean, almost every single time, there's a high likelihood that backward citations are going to be for a component of the patent that wasn't qubit generation. So you're tightly focused on qubit generation in this particular case. And if there happens to be a backward citation to a independent claim in there that was something that was even an examiner citation, there's all sorts of circumstances that can come up that a citation, a backward citation, is going to show up on a document, and it's not really directly on point. I mean, certainly it's got something to do with it, but that's even what we were talking about when we put together the gold standard. The gold standard, the positives are all qubit generation, but the negatives, it's not like they're completely outside of the realm of quantum computing. And I think this very same thing is very, very likely to happen here with citations. And so while this method is I think, a fantastic way for a very practical, I mean, no complicated math, but a real practical. I mean, let's get down to what people are going to want to do as a researcher. You know, is it bringing back the things that are most likely to be of highest interest? And this backward citation approach that you've taken here, I think, is a very solid way to do that. I'm going to let you go ahead and continue. We've got 3 questions that have come in. Maybe when we're getting to the point where we're going to make that transition from you to Rohit, then I'll ask those at that point. But I just wanted to throw that in there before we got too much further along. That I'm not shocked. I think 12 out of 16 is fantastic, and the 4 that you mentioned probably weren't all that on topic to begin with.
Sure. Thanks, Tony, and that's exactly why you know, we what do you say, we just wanted to explain it in very simple way, because at the end of the day, that's how a typical examiner or anybody who's doing a novelty search would really want to benchmark a semantic search, you know. And now we do have some more analysis here, which in the interest of time, because we want to also show the comparison with the qubit data set. I'm just going to kind of just show it off my notes here, that for families prior to the record are basically the citations matched. The first 50 results, we were able to match the backward citations, and they came at these positions. You know, I've removed the first position because that was the record itself, and beginning the others. So these are all the backward citations, and they matched at 1, 2, 3, 12, 23, 38, and 45. So we were able to capture a higher percentage in the first 50 results against the semantic search done from the text of the record. So that's that completes our analysis against the backward citations. And in order to really, now the next question we want to ask ourselves from this data set is 512 families. We've taken a record which is highly ranked and it's related to qubit generation. Did the semantic search really capture qubit generation, or did it really go beyond other things? So the brute force, or the simplest way to kind of really do that analysis is not really, you know, from here. I don't have a query to do that, but what I've really done is we've done that comparison in Excel. What we did is that we've taken your gold standard data set, we took all the records there. I do have this Excel present here. These are your data sets that are basically, you know, going all the way till 5,000, I think, records spread across 1,500 families. And these are the classifications that you have assigned in the data set. And these are our semantic search results here. And all we did was we did a, you know, a VLOOKUP to match which ones of these match into the data set, and what are they classified as positive and all, and then we counted the positives and the negatives. So it's a very simple Excel based comparison just to drive you know, how good our results are. Now obviously the data set is of a particular time period. So what we did was we just to kind of explain, I'll go back to the slide here and just explain. So we restricted the 512 families to the same date range as the qubit data set. I believe it was somewhere till 2019, and the earliest one I don't remember right now. And that gave us 127 matching families, out of which positives were 113 and the negatives were 14. So that gives a kind of a analysis of how many patents in the semantic results, from the 127 that really fell in the range of the qubit data set. How many of them were on qubit generation, and how many false positives were shown in the result, and unfortunately I don't have anything on the application to show other than the same 512 results, but it was all analysis we had to do outside. But that's really how this semantic search compared against the qubit data set, and it gave an indication towards the quality of the semantic results, and so approximately 89–90% of them, to summarize, are on qubit generation, and then we've got the rest are probably outside.
Well, I think this is pretty fascinating. The most impressive thing that I'm seeing here from this is that this is a single example. Exactly. Ordinarily, in order to get levels of recall and precision approaching these types of levels, you'd have to have 10, 15, 20, 150. It's not unusual, not uncommon to say training a system with half of the positives, for instance, 250 examples. So we've seen a variety of different cases where the training set is certainly much larger than a single document. And so it's a little different case, because this is semantic retrieval. And so, but it's still pretty fascinating and pretty solid. I mean, it suggests, pretty good results, pretty steady results, that a single example is providing that type of positive versus negative output.
Sure. Thank you, Tony. And really, I know the data set is designed more for categorization, but that's really how we try to demonstrate how good the semantic search is, by leveraging the context and the data set. So this is how this is how we thought it could closely be used to kind of show the accuracy of the semantic search and how good it performs. And I'll be happy to also share these Excel and these calculations and my notes if somebody's interested. Then just feel free to get in touch with me, because for full transparency, people can really dig into the data if they like. So moving forward, I'm just going to set the context of before I hand it over to Rohit and maybe take one or two questions. What we've now done is for showing examples of our categorization, and also for showing examples of some level of analytics that we do using the scoring. We created this qubit generation data set. What we did was we added the qubit data set positives, and we also prepared a search query on qubit generation because the data set just belonged to a certain time period. So we added further families from it. We did restrict our query to 2000 and beyond, and we excluded one-member families from China, the utility models and certain, just to kind of keep it a little bit concise. And with this data set, we've actually prepared a report. So if I just go back here, and I'm just going to, so so these are those 3198 records, or they're basically one member per family. So there are 3198 families that I was talking about in this qubit generation data set that we prepared for the remaining part of the demonstration. And my colleague Rohit will use this 3198, this project here, to kind of demonstrate how the categorization works and how those analytics work. So Tony, if you could make Rohit the presenter.
Okay, yeah, I want to go ahead and ask a couple of these questions.
Yeah, sure, absolutely. Let's do that first.
Yeah, well, I'll make him presenter first so we can start queuing that up. So okay, you are now the presenter, and please feel free. There you go, sharing your screen. So a couple questions very quickly. The first one I think is something we can answer pretty quickly. initially, when you were talking about the approaches and the rules-based approach that you took, you mentioned vectors. And
Yes.
so there was a question about a vector suggests maybe a support vector machine or something, but of course vectors are just the construct that takes the words present, and if a word is present, it gets a 1 in the vector. If it's
Absolutely.
not,
It's a representation for a sequence of words, a bag of words. It could be a sentence representing as a vector. Yeah.
but it doesn't imply any sort of particular method. It's just a common means by
Yes.
which documents
No,
are broken down.
The vectors are just the inputs to the data modeling, and against each of them various analytics is done. So if your question is, you used SVM as the SVM decomposition, or I believe that the question was whether we use SVM or not. That's not the technique that we are using internally, if that's what you're asking.
Yeah. All right. Second question. Do you use the IPC CPCs to provide context to the text embedding? For example, that a given word may have a different embedding based on the IPC CPC of the source document. Now, embedding, of course, for those folks who it's a bit of a technical term that refers to certain machine learning algorithms like Doc2Vec and various other things like that. So
Yes.
embedding has a very specialized meaning in that particular case. But how would you address that as far as
the answer is yes. The answer to that question is yes. That we do that's why we use, and so because the embeddings can change in different contexts, basically in different classes, and that's so yes.
Okay. And finally, for right now, there was a question about the terms that the system selected based on your text input. Does your system support adding additional terms outside of the selected highlighted ones that were provided by the system?
Absolutely. You could just use your mouse and select those words. You could use the cross mark to remove the selected words. And if you're saying adding words which do not, you'd probably just want to add them to your paragraph before you come to this the highlight stage, because the words that are highlighted there are pretty much from your paragraph. But what happens then? What those words go along with the context into our rules engine, and it looks at what closely held concepts are vectors are around it, and then the comprehensive search against semantic search is eventually done in the back end.
Fantastic. And Rohit, if you want to maybe provide a little bit of an introduction for yourself. Manish mentioned what your role in the organization, but maybe a little bit about how you came to join them.
Okay, so I initially joined in the sales team. So I was just a business developer. I joined as a BD, but then later on, after frequent interaction with the clients, I was promoted to customer success manager. So for the past 12 years, I'm actually handling lot of our main clients. So any queries related to PatSeer, I'm the one who usually addresses them.
Okay, great.
Yep. Okay, so coming back to the webinar, to this particular topic. So today I'm going to show you how auto categorization can be done in PatSeer. So in PatSeer, as Manish has already explained you, we are using relevance. We are using the relevance when we are doing the semantic search. So relevance is basically finding out all the main patents that are like Manish showed you, how relevance is picking up all the relevant documents. So this relevance is actually used in the backend to also categorize the patents. So the only difference is that in the semantic search, we use the input as a paragraph, but in this particular case, when it comes to the categories, it picks up the category names, and based on that, it starts categorizing the patents automatically in the background. So usually patents are categorized based on the processes or the different materials that are being used, or it could also be categorized based on the application area, or it could also be based on the technologies. Now, usually, like the traditional ways to categorize the patents is like, one is like the manual way, wherein like you will go through each and every document, and after reviewing those documents, you will start pushing those records into the category. The other way is like the semi-automated way, which is like you will make use of the different filters that are present, and you will create a sub-search query. And based on that, you will start pushing the records into the category. So now in the semi-automated way, there's one challenge, like you should be a search expert, because you are actually creating a sub-search query and then pushing those records into the category. So both these ways, like there's one challenge, like both these ways are basically very much time consuming. Like you will have to put in a lot of efforts, as well as you will also have to put in a lot of time in order to categorize the patents. So to overcome this, what we have come up with is the auto categorization. So in auto categorization, as mentioned previously, we use the relevance. So I just switched to PatSeer now. So as you can see, I have created some predefined categories over here. So there are like two ways by which you can create these categories. You can take the help of the unsupervised clustering engine that we have, which basically creates some keyword topics and themes. Those are basically the raw technological terms that are present in your project. So using that, I have taken the help of that, and I have created some categories. And the other approach that I have taken over here is like I have created those categories manually from here. So even if you have some categories at your end, then you can also use this import functionality, using which you can easily import all the categories in one go inside a project. So once you have set up a base in which like you have created all the categories, you can use this autofill option. So in autofill option, what it does, like first you'll have to select the portion of the patent on which you want to categorize these patents on. So you can either select title abstract, or it could be full claims, independent claims, or it could be the description. So you can select any one of these portion of the patents. So for this particular case, I had selected title abstract and independent claims. And along with that, if you want, you can also supply a thesaurus file. So a thesaurus file can have synonyms in it, and you can have, like, you can enter those words, like you can have also add truncations while adding those keywords in that thesaurus file. So even that is possible. So in reality, actually, there is no need to use the thesaurus, because in the backend, we are using relevance, and we are expanding the terms that are present in the category section, and we are also looking for the similar documents. But still, if you want to further fine tune it, you can definitely supply a thesaurus file over here. And once you supply this file, the clusters, like the automatic clustering will take place, and it will push all the relevant records into that particular category. So the autofill option, like it is not just purely looking for those keywords in that particular section of the patent. Like say, for example, like as I told you, like I had selected title abstract and independent claims. So it is not just looking for, say, for example, I have a subcategory over here, which is like a Toffoli gate. So it is not just looking for this particular gate in title abstract and independent claims. So it is also looking for the similar patents which are talking about this particular gate, and is also pushing those records into it. So if I maybe, like if I just do a search over here saying like TAI, which is like title abstract independent claims, and if I do it like Toffoli gate, then I'm pretty sure like I'll just get less number of records over here. So in this case, if you see, I have like 49 records, but if I just do a plain keyword based search, then I will get pretty less number of records over here. So this is how the auto categorization works. And once you have a good set of like once you have properly categorized all the patterns, then you will have a lot of different options to play with. You'll have a lot of different features in which you can actually make use of these clusters that you have created, and sorry, the categories that you have created. And yeah.
So Rohit, before you just go into, can I just prompt there before
Sure.
you go into showing what we can do with these categories? So unlike unlike the example that we compared the semantic with the data set, in this particular case, uh, uh, because we were doing this categorization within the whole qubit generation data set itself, benchmarking it against the data set in some way didn't really kind of make sense. So but we did benchmark these with complex queries. We do have some comparisons, some comparisons of that. In the interest of time, we are not covering that because we weren't really sure what to do with the categories. But like what Rohit said, is that these categories are not as simple as just searching in title abstract independent claims for Toffoli gate or Hadamard gate or things like that. But it's using the context, it's expanding the context based on what the rules are embedded in ReliSense against it, and then running the search. And so it's more than just that. The main aim here is basically to have the user first define the categories as per the way they understand the business, and that's why this is not as good. This is cannot be compared as what you call as unsupervised clustering, wherein it just throws you different terms from the text which it finds based on various ranking models. But here you can create up to 5 level deep categories the way most companies probably already have taxonomies that they can import into this particular set, and then they can just leverage this option to quickly take a alien data set and quickly map it against their taxonomies, which they are so very familiar with, and then immediately begin analyzing, running some basic analysis. So it kind of like saves a lot of time there. And we don't really say that this is a replacement for, of course, manual categorization. No one will ever say that. But yes, we've compared it with search queries, like complex search queries for some of these, and the results were fairly, close. Go ahead, Rohit.
Yeah. Okay. Yeah, so once you have a good set of categories with you and you have categorized the patterns, then you can make use of these categories itself to conduct some advanced analysis. So I'll just show you a matrix, like this is a two-dimensional matrix that I will quickly generate. So in this case, I'll take the categories, and yeah, on the other side, I'll take the keywords. Okay, so now using these categories itself, I'll be able to, like, you will be able to have some more insight. Like on one side, what I have done is like, as you can see over here, you have all the categories, and on the other side, what you have is the list of the keywords that have been generated. Now, by just looking at this table, you can quickly see where there is a common intersection, like where there is a custom category that I have created, and if there is any. So basically, you can see the common patents in the keywords and the category section over here. And this map is highly tweakable. Like you can just quickly change it to the heat map, and you can now, like, it basically helps you to understand this matrix more fast. Like you can just quickly say where there is the highest occurrence of the patterns by just looking at the map. Also, these categories that you see over here, these can also be viewed in the form of charts. So we have a separate quick stat section in which you can actually view the charts based on the categories that you have created, along with the standard fields that are usually available in the graph section, in the chart section. So, so this was about the how the AI has been used.
Before you move on, let me ask a quick question. Mm-hmm. That previous slide was pretty impressive. Now, by keywords, could you say limit the keywords to just the keywords from the full set of claims or the independent claims? Is that a possibility there? Because I mean, what that really looked like to me, I get this question all the time. It kind of drives me a little bit crazy. You know, the idea of looking for white space. All right. Mm-hmm. And that's white space is nebulous in the sense you don't know what what you didn't look for. And so white space in and of itself, but the only approach that I've ever seen that looks at least reasonable for talking about white space as sort of a broader concept is something like this, where you're saying, okay, well, if we've got qubit generation and we've got semiconductor loops versus topological versus quantum dot versus XYZ, we've got 6 or 7. And then you've got all of these claimed keywords, and you can start to look for these overlaps using the heat map, for instance, to identify the areas of similarity and dissimilarity between those different approaches. And then even be able to say, well, is there an opportunity or is there a possibility to apply something from this type of qubit to another type of qubit, where I can see right now that that's not currently being done because it's just not lining up in the matrix. So this this looks like a really solid method for doing a pretty advanced and pretty detailed, even micro level analysis to get into some really specific details. And so by the nodding of the heads, I'm guessing that I've got this right, that this is a reasonable assumption.
Absolutely, absolutely. So these keywords are part of the unsupervised clustering algorithm built in, and we call them as clusters. And at the generation of the clusters, you can specify if you want them specifically only from claims or independent claims or title abstract or description. So you can select the section and then generate them, and then you can use them for all sorts of X versus Y analysis.
Okay, so I want to do a quick time check. The majority of our audience is still with us, so thank you very much. Don't forget, there's only 6 questions on the survey. Please answer those questions. It should take less than 2 minutes. If you have to leave right on time, we're going to keep going here for a few minutes. There's one question in the queue, but I want to let you go through a little bit more, and maybe in another 2 to 3 minutes, we can start looking at that question and any other ones that come in. So please continue.
Sure. Okay, thanks. Okay, so the next part that I'd like to show you is about the quality parameters that are present in PatSeer. So in PatSeer, you can do the quantitative as well as the qualitative type of analysis. So when I say qualitative, what we do is we pick up almost 30 plus parameters from the actual patent document. And based on those values, we come up with 4 different scores. So as you can see on the screen, we have the citation, market, legal, and intrinsic. So based on those 30 parameters, we come up with these scores, and the weighted average is then calculated, and based on that, the 360 quality score is calculated. Now this 360 quality is given at the family level, and then further you can actually if you want to do some portfolio analysis, then at the portfolio level we give this scoring we present them in 2 forms. One is the 90th percentile, which is which is being calculated the 90th percentile value over the patent family scores, and the other is the portfolio value index, which is the sum of all the 360 quality scores that are present in the family. So now these scores are basically used to you can make use of these scores to find out some of the emerging players in the space, or so there are a lot of different analysis that you can do basically by using these scores. So I just quickly jump to the next part. So this is the competitive landscape. So if you see this particular map, on one side what you have is the portfolio size, and on the other side you have the 360 quality, which is the portfolio value index. And on the map what you see are a couple of circles. So on this map what you see is typical D-Wave system, IBM, and Alphabet, Microsoft. So these are most prominent players in this space. But then having access to these kind of chart, you can also, what you can find out is some of the players that are small in this space, but then they can be eventual threat in the coming future. So just to showcase 2-3 companies in this particular space, if you see on the top left quadrant, you have Anglo American Corp. So if you see its 90th percentile is way on the higher side, though its portfolio size is less. So that is why the size of the bubble is small, if you can see over here. But if you see the color of this circle, it is red. So what we have done is in addition to the the size and the 360 quality that you see on this map, what we have also done is we have colored this circle based on the market quality. So the red indicates that it has a very high market quality. So basically, from this map, what I can tell is that Anglo-American has like the patents that it has in its portfolio. They are very powerful patents. They are very strong patents, and that is why they have made sure that they have been protected in all the main countries. So the countries which has the higher GDP. So that is the reason why if you see the Anglo-American Corp, it has a red color circle over here. And this company is coming up because because the patents that it has is basically belong to the element 6. So element 6 is a subsidiary of the Anglo-American Corp. And the chart that I have shown to you right now, it is basically showing you all the current owners in this particular space. So Element 6 is the company that is working on the diamond-based quantum computing. They are creating time crystal using the quantum computers. And to support this, we have also added some articles over here. Also, if you see over here, we have the University of New South Wales. Here again, if you see, the size of the bubble is bigger compared to Anglo-American. The reason is like University of New South Wales has more number of patents compared to it. But then again, here like the value index is on the higher side, and even the circle is in the red color, which basically means that even University of New South Wales, they are also protecting their countries. Sorry, they are also protecting their patents in all the main countries which are having the higher GDP. So if you see at the recent activity done by the New South Wales, they are basically into chip-based quantum computing, and they have almost achieved like 99% accuracy in this. So for this also, we have added a couple of articles over here.
All right, well, let me stop you there so we can ask a couple of questions before we hit the top of the hour. Yeah, Element 6 is a well-known player, and it actually has got a partnership with Northrop Grumman, and so that's a key player. So that doesn't come as a surprise. Okay, so a couple of quick questions. Can the category information be used to visualize or show how they have changed in importance over time? So is it possible to use how the category is line graph basically to
Absolutely.
show the categories
It's
over time?
possible. There's a whole set of charts possible using the categories. Actually, the system is it's very flexible in that there's a lot of predefined charts also that show like the like a innovation timeline against each of those categories. So you'll know that which categories were probably active 10 years back but are no longer active, or all of that. So there's the quick stats section. There's just there's just charts after charts on it. Yeah.
Okay, and there's one other question here, and we're right up against the hour, and so
Yes.
I think I'll give you a chance to answer it, but maybe it's better left sent as a response, and that was, how is the market quality determined? And I think they're looking there maybe for a little bit more of an explanation of the formula involved. This question will show up in the registration report, and so if you want to say something quickly about it. Otherwise, we'll leave that for you to explain to that person in a little more detail after.
Sure, we are really at the end here. We just had one or two more charts which were similar, but we are going to skip that in the interest of time. All of these are present in the PowerPoint, so people can have a look at it. I will quickly come back to that question and state that market quality is based on the coverage of the family where it is active currently. The currently active family members, which countries they fall in, and the countries are weighted by the order of GDP. So obviously, the key countries is if it's filed, granted, protected, alive. Or if it's a pending application there, then it has a certain weight. If it's a granted patent in those countries, it has a higher weight, and all of that combines into the market quality for the family.
Okay. Well, again, we're a little bit after.
Sure.
The majority of people have stayed. Do you have any quick closing comments?
Sure, I can take that up, and our intent in this webinar was to show how the software works against the qubit data set and show different examples of semantic search, categorization, and a little bit of analytics on the qubit data set. And we hope that this helped you get a little bit of a sneak peek into what capabilities PatSeer has in this sector. So thank you everyone for joining us for this webinar, and we hope you found the information useful and worthwhile. So thanks, Tony, again for helping organize this webinar.
Yeah, you guys did a terrific job. Thank you so much for the transparency, the examples, the details. You've done a tremendous job with this. It's funny, you and I have known each other for almost all that entire 15 years. And so to see the progression of where you were in Germany at ICI, or France actually, at ICIC 15 years ago to where you are now is phenomenal. And so you should be commended for really sticking to this. I mean, this is a tough road to hoe, and you've gotten here now after a very long period of time and dedication to the industry. Once again, there's a survey, 6 questions. Please fill out the survey, especially if you're interested in a free trial. And with that, I'm going to go ahead and close the webinar. Again, thank you very much to the presenters, to all of you who joined us today, and we'll look forward to seeing you for episode 9. So thank you very much.
Thank you, everyone.
Thank you.
Thanks a lot, Tony. Thank you. Bye-bye.
Thank you. Bye.